Okay, in lesson 6.5, we talk about the dot product. So part 1 here says the dot product says for any two vectors v with components v1 and v2 and vector w that has components of w1 and w2, the dot product of v and w is denoted as v dot w and is defined as the vector v dot vector w is equal to the components of vector v, which is v1 and v2, dot the components of vector w, which was w1, w2. And so we're going to take the first components of each of them and multiply them, plus the second components of each and multiply them. So example 1 says to find the dot product v dot w, a, with vector v having components of 2, -3, and vector w having components of 3, 4. Alright, so let's find for a, let's find v dot w. So we know that means we're going to take the components of vector v, which is 2, -3, dot the components of vector w, which was 3, 4. Alright, so our formula tells us we're going to take the first two components and multiply them, plus the second two components and multiply them. So 2 times 3 is 6, plus -3 times 4 is -12, and 6 plus a -12 is -6. So v dot w is equal to -6. For b, it wants us to find v dot w given that vector v is equal to -3i plus 5j and vector w is equal to 2i plus 3j. Alright, so we're looking for vector v dot vector w, which then is going to be equal to vector v is -3i plus 5j dot vector w, which was equal to 2i plus 3j. Now remember, we can take that -3i plus 5j and that 2i plus 3j, and we can write them as vector components. So this is the same thing as saying for vector v, we have components of -3, 5, dot, and vector w, we have components of 2, 3. Then we do just like what we did in a, we're going to multiply our first components, plus multiply the second components, and then algebraically solve this. -3 times 2 is -6, plus 5 times 3 is 15. Add them together and we get 9. So v dot w for part B is equal to 9.